Hello and welcome back to another video. In this video, we will have an introduction to OWL, an ontology language for schematic web, and then learn to visualize it using an online visualization tool. Stay tuned. You are watching the Artificial Intelligence and Data Science channel. Subscribe for more amazing videos. OWL stands for Web Ontology Language. Wait, isn't that WOL? Well, for easier abbreviation and pronunciation, W3C made it as OWL. The W3C formally describes OWL as a semantic web language designed to represent rich and complex knowledge about things, group of things, and relation between things. In simple words, we can say OWL is a semantic web language which is designed to represent ontologies. It is one of the core semantic web standards along with RDF and SPARQL. The current version of OWL, also referred to as OWL 2, was developed by W3C OWL Working Group and was published in 2009. And this is the W3C recommendation since 2009. OWL 2 is based on a description logic Schroik D, whereas OWL 1 is based on a description logic Schoen D. The OWL languages are characterized by formal semantics. They are built upon W3C's XML standards for objects called RDF. OWL and RDF have significant applications in research, medical, and commercial aspects. Speaking about ontologies, an ontology can be described as a way of showing the properties of a subject area and how they are related, by defining a set of concepts and categories that represent the subject. Every academic discipline creates an ontology to limit complexity and to organize the data in the form of a knowledge representation. New ontologies help to solve the problem within that domain. The main components of an ontology are concepts, relations, and instances. It is similar to the triples format that we discussed in the semantic web video. If you want to know more about the semantic web technologies, check out my previous video on semantic web. I'll add a link to it in the description below. A concept represents a class or class of entities or things within a domain. Classes may classify individuals or other classes or a combination of both. For example, consider car, which is a class of all cars, or an abstract object that can be described by the criteria of being a car. Another example is thing, which is a class of all things or the abstract object that can be described by the criteria of being a thing. Instances refer to the things that are represented by the concept. It may include concrete objects such as people, animal, table, as well as abstract individuals such as numbers and words. Strictly speaking, ontologies need not include instances as it is supposed to be a conceptualization of the domain. A combination of an ontology with an associated instance is known as a knowledge base. Relationships in an ontology specify how objects are related to other objects. For example, John likes football. Here, likes denotes the relationship between the object John and the object football. There are two types of properties that exist for OWL. They are object property and data type property. Object properties are used to link individuals to individuals. As we can see from the example, drive wheel type is an object property that links drive wheel configuration and car. This indicates a different drive wheel type available for the car. Data type properties are used to link individuals to data values. Data type properties can have data type as range. As we can see here, liters is a data type property that can be used to denote the quantity of fuel that can be stored in a car, whereas type is a string type property used to denote the type of fuel used in the car, such as premium, extra premium, or ordinary type of fuel. Okay, since we have a basic idea about OWL, let's try visualizing it in the online visualization tool VOWL. I've added a link to VOWL online editor in the description below for you to check it out. Let's start. So we are in the visualization page. We go to modes, editing, ontology, create new ontology. We'll create the ontology about vehicles, give a description. This is an ontology about vehicles. Okay, then we go to class, double click anywhere to create class, we create vehicle ontology. To add subclass, you can go to subclass, double click car and just drag and link it to get a subclass. Motorbike, airplane, bus, train. Okay, now let's add an object property for our class car. For that, we go to object property and then we click here. We name it as drive wheel configuration. To indicate the different drive wheels. It adds subclasses for it. All-wheel drive, front wheel drive, rear wheel drive. We'll add another object type, object property, steering wheel, this is to show the steering wheel position, and give subclasses left hand drive, right hand drive. We'll add another subclass, object property, fuel, to indicate the fuel type. Okay, and we'll add subclasses, petrol, diesel, electric, hybrid. Okay, now let's indicate the use type, object property, type, indicate the use type, subclass, taxi, privately owned, company, driving school. Okay, now we have the basic object properties. Let's define some data type properties. Today, let's start with the color. I go for a string, go here, click add, data type property, color. Then let's give the number of gears, which is an integer type property. Gears. Add one more. Seating capacity. Number of hours. Okay, there you have it, your basic visualization. Now if you want to reduce the gap, you can go to zoom control to change the gap between the objects. If you want to delete something, you can just click the X to delete it. Hey, if I have an object property also, you can just delete it. Sorry, if I have a data property also, I can just delete it. There you have a visualization. Now to export it, you can go to export and export it as any of the formats required. There you have it. That brings us to the end of this video. Hope you got a basic idea about web ontology language and its visualization. See you in the next video.